You ever just stop and think about the insane amount of power you've got sitting on your desk or, right there in your hand? We've got these amazing machines that can do just about anything, but there's this hidden force, right? A kind of master director making it all happen. Well, today we're going to pull back that curtain. We're going to meet the conductor of this digital orchestra.
And I mean, that's the real question, right? What is it that turns this box of silent parts of silicon and metal into something that lets us connect with each other, create art, basically run our entire world? What gives it life?
Okay, so let's think of it like this. Imagine you've got the world's best musicians on a stage. You've got your CPU, your RAM, your hard drive. These are all virtuosos, the absolute best in the business. But without a conductor, what do? Nothing. They just sit there. It's all this power with zero purpose. Just a silent, uncoordinated stage.
And that is where this comes in. The operating system, the OS. That's the conductor. It's the essential piece of software that steps up to the podium, taps the baton, and turns all that silent potential into a beautiful, coordinated symphony. It's the one thing that connects you to all that powerful hardware. All right, so how does this conductor actually do its job? Well, first things first, and this is maybe its most important job, it has to manage all the different soloists who all want to play at the very same time. We call this process management. I mean, think about it. It's something we completely take for granted every single day. Right now, you're listening to me. Maybe you've got a web browser open, music playing in the background, and bing, an email notification just popped up. How in the world does your computer juggle all of that at once without dropping a single note? Well, here's the secret. The OS sees each one of those tasks as a process, and a process is really just a program that's in execution. It's running. So your browser, your music player, that little email app, each one is like a soloist, totally demanding the conductor's attention and resources from the main instrument, which is, of course, the CPU. So the way the conductor handles this chaos is by moving every soloist through a few key stages. Think of it as the life of a process. First, it's new. The soloist just walked onto the stage. Then it's ready, waiting in the wings for their turn. When the conductor points the baton, it's running. It's actively playing using the CPU. Now, if it has to wait for something, maybe for a web page to load, it gets blocked. And finally, when the performance is over, it hits exit. And this diagram really shows you the conductor's genius strategy. See how a process gets dispatched from the ready state to the running state. But the OS is a strict conductor. If one soloist hogs the spotlight for too long, a timeout happens, and boom, it's sent back to the ready line to wait its turn again. And if it needs something, like that download we talked about, it gets moved over to the block state until that event occurs. It's this constant, ridiculously fast shuffling between states that creates the illusion that everything is happening all at once. It's the magic of multitasking. Okay, so the conductor is juggling all these soloists like a master. But what music are they actually playing? Every orchestra needs its sheet music, right? And that brings us to the OS's next huge job, acting as the librarian for a massive digital music library, which is really just all of our files and programs.
And this is a perfect way to picture the two kinds of memory your computer has. Over on the right, you've got the grand library. That's your hard drive or your SSD. It's the permanent, vast storage for every piece of music, every file you've ever had. Then, on the left, you've got the conductor's stand. That's your RAM. It's incredibly fast, but it's also temporary. It only holds the sheet music for the songs that are being played right this second.
So, the OS has to be this master librarian, right? Its whole job is to organize that massive library so that any piece of sheet music, any file, can be found in an instant and rushed over to the conductor's stand the moment it's needed.
And how does it do it? Well, it uses a system that you've probably seen a million times. It's this hierarchical file structure, basically like a giant digital filing cabinet. Everything starts at the very top, in the root directory, and then it just branches out into folders, which have more folders inside them, and on until you get to your actual files. It's a brilliantly simple and efficient way to keep track of, well, potentially trillions of pieces of data.
All right, so we've got our solists, we've got our music library, but how do the musicians actually get their instructions? How do they talk to the conductor? This is where the OS interface comes into play. I mean, seriously, think about it for a sec. When you're in a document and you click Save, your word processor doesn't have a clue how to actually write data onto the physical hard drive. It just can't. So how does it make that happen?
It does it with something called a system call. And a system call is basically the program's official, polite way of tapping the conductor on the shoulder and saying, "Excuse me, I need a favor. Can you please perform this service for me?" And whether that service is saving a file or getting more memory or talking to your printer, it all goes through these official, carefully controlled requests.
Okay, but what about you? What if you want to talk directly to the conductor? Well, that's what the command interpreter is for. Think of the command prompt on Windows or the terminal on a Mac. That's your direct line. It lets you give explicit commands right to the OS. No middleman, no application. It's kind of like having a backstage pass to give notes straight to the conductor.
So you put it all together, right? You've got the soloists, the library, the direct commands, and what you get is the final performance. It's this seamless, powerful symphony of computation that just works.
So let's just do a quick recap of the conductor's massive job description. We've talked about managing the soloists. That's process management. We've talked about organizing the library, file management. But it also handles the stage crew. You know, the people managing the lights and sound? That's your I/O devices. It communicates with other orchestras. That's networking. And of course, it acts as the security guard for the whole venue. It is a huge, huge job.
And believe it or not, the job doesn't even stop there. The OS is also constantly monitoring the whole performance, looking for bottlenecks. It's keeping track of which musician is using which instrument. We call that job accounting. And it's always on the lookout for errors, making sure one little sour note doesn't bring down the entire show.
You know, this quote from our source material really just nails it. It says that all these different parts of the operating system work together to make everything just function easily. They provide a stable, efficient environment for us and for our apps. At the end of the day, it's about letting us do all the amazing things we do without ever having to think about how the music is actually being made.
So, the next time you pick up your phone or sit down at your computer, just take a second to remember that invisible conductor working tirelessly behind the scenes. And here's a final thought to leave you with. Our digital orchestra, it's getting so much bigger. It's not just computers anymore, is it? It's our phones, our cars, our watches, our entire smart homes. So the real question for the future is, how is this conductor, the OS, going to have to change to direct a symphony that's made up of literally trillions of devices?